Okay, good morning to all of you. In our today class, we are going to discuss about gamma distribution. Okay, in our previous class, we have been detailed discuss about your uniform or regular distribution. About this distribution, we have been discussed moments of uniform distribution, moment generating function of and numericals, some numericals about uniform distribution, and in this class we are going to discuss gamma distribution. So let's start. Here the definition of the gamma distribution, that is your the continuous random variable x is to follow a gamma distribution with parameter lambda greater than 0 if its probability density function, or that is your PDF, probability density function, is given by or is going to be written by fx will be equal to e to the power minus x into x to the power lambda minus 1 by gamma lambda, where lambda greater than 0 and x varies from 0 to infinity. Otherwise, for other values of x, this PDF is to be 0. This is the definition. Okay, now we have to prove that whatever it has been defined, the PDF for the gamma distribution, is it true or not? If it is true, then the limit from 0 to infinity, if we are going to be integrate, it has to give the 1 value. So it is given the 1 value. See, fx dx 0 to infinity fx dx, that means PDF of the gamma distribution into dx. We have to integrate from 0 to infinity. What we are going to get? See, we are going to get 1, but how it is? See, 0 to infinity fx is equal to this much. I have been just substituted over here into dx. We know that gamma lambda will be a constant taken outside the integration. 0 to infinity e to the minus x, x to the lambda minus 1 dx, right? So this is nothing but your gamma lambda. You just recall that in our previous class I told that if it is a integral, it is written like this: 0 to infinity e to the minus x, x to the power n minus 1 dx, then that is nothing but called as your gamma n. Previously we have been discussed. Okay, here n is there, and in this integral lambda is there. So for n it is gamma n, for lambda it will be gamma lambda. So already one gamma lambda is here, cancelled out 1. So hence it has been proved. Next we have to go for the moment generating function, or MGF, about origin of gamma distribution. We know that in general MGF about origin is nothing but mxt equal to expectation of e to the power tx, that is nothing but minus infinity to plus infinity e to the power tx into fx dx. This fx is nothing but your PDF for your continuous distribution, and for discrete distribution this is nothing but called as the PMF. Okay, probability mass function, but for continuous distribution this is called the PDF. In general it is like this, but in this case for your gamma distribution x varies from 0 to infinity. So here mxt will be equal to 0 to infinity this much. Okay, this much, or you can write like this, that in general e to the power tx fx dx. So minus infinity to 0 e to the power tx fx dx plus 0 to infinity e to the power tx fx dx. But in this case, in our gamma distribution, instead of x in between 0 to infinity, all the negative values, for all the negative values of x, that will be 0. That means minus infinity to 0, fx is 0, so entire integral value will be 0. So this step I have not written over here. If you want, you can write down in your note, but for this case I have been written directly mxt equal to 0 to infinity e to the power tx into e to the power minus x into x to the power lambda minus 1 divided by gamma lambda into dx. Okay, here gamma lambda is constant taken outside, 0 to infinity e to the power, here it is dx, it has been written e to the power minus x to the power lambda minus 1 into dx. 1 by gamma lambda is there 0 to infinity. Here these two powers has been added up and taken minus common. Then e to the power, then e to the power minus, you can see it will be 1 minus t into x. See, if I will add it, it will be tx minus x. If I will take minus common, then it will minus 1 minus t into x, and this term, that is your x to the power lambda minus 1 into dx. Okay. Now, here same thing again I have been written in the next page. It will be easy for me to explain that. That is 1 by gamma lambda 0 to infinity e to the minus 1 minus t into x to the power lambda minus 1 into dx. Now we have to put 1 minus t into x equal to u, and so hence if we are going to consider 1 minus t into x equal to u, so that implies 1 minus t dx equal to du, right? Or here you can see if this one equal to u, x will be equal to how much? X will be u by 1 minus t, and here dx will be how much? Du by 1 minus t. Okay. And here the limit, if whenever x equal to 0, u also will be 0, and x equal to infinite, if we are going to consider, u also will be infinite. Now we are going to put this value, that means x value and dx value over here. We found 1 by gamma lambda 0 to infinity e to the power here 1 minus t is there, so 1 minus t x has been considered as u. So e to the power minus u into x will be how much? T u by 1 minus t, right? So u by 1 minus t to the power lambda minus 1 into dx. So dx will be how much? Du by 1 minus t, du by 1 minus t. Okay. So 1 by gamma lambda 0 to infinity u to the power lambda minus 1 e to the power minus u, and this one 1 minus t to the power lambda minus 1 into 1 minus t into du. Okay. Now here you can see 1 minus t to the power lambda minus 1 into 1 minus t to the power 1. So if I will add the power, then it will be lambda minus 1 plus 1, only lambda will be there. So I taken outside 1 by 1 minus t to the power lambda, this is nothing, only you just concentrate 1 minus t to the power lambda into 1 by this one gamma lambda into 0 to infinity u to the power lambda minus 1 into e to the power minus u into du, right? This is what? This is nothing but your gamma lambda. How? We know that 0 to infinity e to the power minus x into x to the power n minus 1 dx equal to gamma n. So here instead of x, it has been written as u. Okay. Instead of lambda, here it is n. Okay. Instead of n, it is lambda. Instead of x, it is u only. Just the symbol has been changed. Okay. So if it is gamma n, obviously this will be also gamma lambda, right? So gamma lambda and gamma lambda cancelled out, and we found mxt or moment generating function will be 1 by 1 minus t to the power lambda, or 1 minus t to the power minus lambda. This is your moment generating function of your gamma distortion. Now we are going to go for the moments about the origin, and from that we are going to find out mean and variance. Okay. So we know the rth moment about the origin in general. You can write in general, we know that the rth moment about the origin is rth derivative of moment generating function. That means dr mxt by dt are at t equal to 0. That means we have to consider rth derivative with respect to t of your moment generating function. Then we have to put t equal to 0. That will be your rth moment. This we know very well. First, here we are going to be consider the first moment. That means r will be 1. That means here we are going to consider the first derivative. First derivative of moment generating function with respect to t, d by dt of mx t. Then after we have to put d equal to 0. That will be give us the first moment, that is your mu 1 dash. So d by dt of moment generating function mxt, here we found that is your 1 by, or you can put this one, 1 minus t to the power minus lambda, 1 minus t to the power minus lambda. Then we have to put t equal to 0. You just take the differentiation of this one with respect to t. We can find minus lambda 1 minus t to the power minus lambda minus 1, and differentiation of this one 1 minus t with respect to t will be how much? Minus 1. So here 1 minus sign will be plus lambda 1 minus t to the power minus lambda minus 1. Now we are going to put t equal to 0. If t equal to 0 here, then this will be 1 minus 0 or 1 to the power this much. 1 to the power anything is, it will be 1. So we found mu 1 dash equal to lambda, that is nothing but also called as the mean or expectation of x. First moment about the origin, nothing but mean, that we know very well, or we can write that expectation of x, right? Second moment, for the second moment we have to consider second derivative of moment generating function, that is your d square mxt by dt square. Then we have to put t equal to 0. Okay, so d square by dt square, moment generating function is nothing but 1 minus t to the power minus lambda, right? So d by dt of first derivative already we found here. First derivative already we found this one, right? I directly substituted this value here. Then d by dt of this one at t equal to 0, right? At t equal to 0 means after doing the derivative, all the derivative, then we have to put the t equal to 0. You know that one, okay? So d by dt of this one. So first derivative of moment generating function, we found this one. I just substituted here. D by dt of this one will be how much? You can see lambda is there, and minus 1 minus lambda minus 1 minus lambda minus 1 into 1 minus t to the power minus lambda minus 1 again minus 1, right? Into derivative of this one 1 minus t is how much? Minus 1. Okay, this is minus 1, right? This is minus 1. So here you can see that if I will take minus common from this, I will get lambda minus 1, but minus will be come outside. 1 minus here, 1 minus here, it will be plus, and we are going to get lambda plus 1 into 1 minus t to the power lambda minus 1 means minus 2, minus lambda minus 2. Then at t equal to 0, we have to put t equal to 0 means 1 to the power something will be 1. So here mu 2 dash, our second moment about the origin, we found lambda into lambda plus 1, that is also represented as expectation of x square. Now variance, we are going to calculate. Variance is nothing but second moment about the origin minus first moment about the origin square. So second moment we found lambda into lambda plus 1. First moment we found lambda. So lambda square will be lambda square. This will be lambda square. So here you can see this will be lambda square plus lambda minus lambda square. Lambda square. God cancel. Variance we found lambda. So here you are going to note one thing, that for gamma distribution, whatever the value we found, variance value is exactly same with your mean. Okay, for your gamma distribution, mean and variance both are equal. Okay, that you have to write down your note as a note. Okay, so here we are going to verify somewhat one thing, that Here whatever we done here, or whatever we found the moments, first moment and second moment, that by using the moment generating function. But these two moments or any moment can be found in this way itself, that we also discussed previously. That is, this is expectation of x. This is c. Expectation of x is nothing but first moment, one dash. So one dash is nothing but expectation of x. Expectation of x means 0 to infinity x into e to the power, this is your pdf into dx. Okay, pdf into dx for your continuous distribution function, that we have to write down the expectation value of x will be like this, right? That we know. So 0 to infinity x into, this is your pdf of gamma distribution, that we know. Here we discussed the pdf of gamma distribution. I just substituted over here pdf of gamma distribution into dx. Here 1 by gamma lambda is a constant. Gamma lambda constant taken outside, 0 to infinity. Here e to the power minus x, x to the power lambda minus 1, x to the power lambda minus 1, here x to the power 1. So if I will add it, we are going to get x to the power lambda only. Here x to the lambda into dx. So here we found that 1 by gamma lambda 0 to infinity e to the power minus x into x to the power, see here x to the power lambda can be written as lambda plus 1 minus 1, no problem. This can be written as wait, 1 second, it is visible, no? It is visible, no problem. So this will be, this x to the power lambda can be written as x to the power, this is x to the power lambda plus 1 minus 1 dx. So what is this? This is nothing but, so what is this? This value will be how much? See, we know that 0 to infinity in general, what we know, 0 to infinity e to the minus x into x to the power n minus 1 into dx is nothing but your gamma n, right? So instead of n, here how much? Gamma lambda plus 1 is there. Okay, so here n is x to the n minus 1 is nothing but gamma n. Here x to the power, instead of n, what we have? We have lambda plus 1. So this integral value will be how much? 1 by gamma lambda into gamma lambda plus 1. And we know that gamma n plus 1 is nothing but n gamma n. So gamma lambda plus 1 can be written as lambda gamma lambda. Gamma lambda got cancelled, we found lambda. So here in this way also we can find the expectation value or mean value equal to lambda. Similar procedure you can follow, and you can found that e to the expectation of x square is nothing but 0 to infinity x square into e to the minus x, x to the power lambda minus 1 into dx by this much, because this is nothing but your pdf into dx, right? So this 1 by gamma lambda taken outside, 0 to infinity e to the minus x, x to the power here lambda minus 1, x to the power 2. So we can get x to the power lambda plus 1 dx, right? Okay, so 1 by gamma lambda 0 to infinity e to the minus x, x to the power this lambda plus 1. Lambda plus 1, how much we can write? This lambda plus 1, we can write lambda plus 2 minus 1 into dx. You can write, no problem. So here you can see, if x to the power n minus 1 dx equal to gamma n, here x to the power instead of n, what is there? Lambda plus 2. So we can write, this is your, this integral value is nothing but gamma lambda plus 2. So gamma lambda plus 2 is nothing but lambda gamma lambda plus 1 into, see this one is nothing but gamma lambda plus 1 plus 1. So this much is nothing but lambda plus 1 gamma lambda plus 1, right? So again gamma lambda plus 1 can be written as lambda into gamma lambda. So gamma lambda got cancelled. We found lambda into lambda plus 1 is your value of this one. Okay, so in this way also you can determine the moments. So I suggest that you have to write down this one in your note, and this you have to do in your rock for your practice, but these things you have to write down your note, okay, for your exam point of view. So this much only. So here we have been completed the gamma distribution and its moment generating function. From the moment generating function we found the moments, and from the moments we found the mean and variance. See here we derived first and second moment. Suppose in your question it has been asked that you have to find out third moment or fourth moment, likewise you have to do, okay. So you write down the note carefully. You have to watch the video, write down the note, and ready for the next class. Next class we are going to discuss exponential distribution. So thank you so much for watching this video. Thank you, and I'll be give the link in the description from where you can download the PDF of this note, okay. So thank you so much. Thank you.